welcome to the course Advanced Reaction Engineering. So, in this course we are discussing the collections and rate data analysis. We will discuss few numerical examples, and on the basis of that we will discuss about the how to solve a nonlinear equations by using Polymath software. So, that we will discuss. Let us say for examples we are considering say reaction C plus B going to C plus D. So, in these reactions if we conduct in any batch reactor, let us say. So, once we conduct the reactions in a batch reactor, so initially let us say the reactant A, that concentration C is used, C naught equals to 0.05 mole per dm³. So, once the reactions has started, A and B that we have charged here and reactions has started. So, T equals to 0, reaction started, then at different times, that may be we can say 300 minutes. So, after that we will stop the reaction. So, then at time T equals to 0, the concentrations initially it was 0.05 and now it is C equals to this 10 to the power 3 is there in the left hand side, we can divide it. So, then actual concentrations we can get. So, then at 50 times means 50 minutes the concentration is this, 100 minutes the concentration is this, 150 concentration is this, 200 minutes the concentration of the C is this, 250 when time is there, then concentration like that up to 300 the concentration should be like this. So, this is the raw data, means experimental data. From the experiments we can collect how the concentration changes along the time. So, for the batch reactors. Okay. So, let us say this particular reactions we want to find a rate equations. So, rate law we can say like this way we can write, or if we consider that B, that component, another component B is the another reactants we have taken excess amount. So, we can put this way and this would be the rate equations, or minus dCA by dt equals to K prime C to the power alpha. This way we can write our equations. Here K prime equals to Ka into Cb to the power beta, this is okay. So, this way we can considering. So, here two parameters are the unknowns. So, that is one is K primes, another is alpha, these two we have to find out by using means regression techniques. So, that will use. So, these equations after integrations or rearranging, so we can write or express in this way. Equations 1 we can write this way, means in the left hand side times and right hand side other parameter, that is K prime, alpha and concentrations at different times. So, that is given. So, these equations, this is means theoretically we are assuming that the reactions is following these rate equations. Okay. But rate law parameters that we do not know, that we have to find out. So, now Ca naught, that is the initial concentration that is known, that is given. So, that we can substitute here. So, then these are the unknowns and these are the K primes and alpha, these are the value. So, at the beginnings or the step 1 means step by step we will solve these equations. So, first we have to assume some value of alpha and K. Alpha let us say 2 and K prime value that may be 0.003, that we are assuming, that may not be this is the guess value, initial guess value of this, that we are assuming. So, that we are expecting that the rate constant may be like this and order may be like this. So, based on that, this is if we put alpha here and K prime here and concentration from the tables, that is 38, let us say at 50 equals to 50, concentration is T equals to 50, concentration C equals to 38, that is given. So, now if we put C equals to 38 here, so then we can get T calculated value, this is T measured value, measured, that is already given. So, by putting this value, calculated time, we can get. So, from this, so this is the measured value, calculated value, maybe a calculated value maybe let us say 40 is coming. So, measured value actually this 38 concentrations that we have measured experimentally, that at time t but when by considering these equations we are putting wants to get these concentrations, then time is 40. So, it is lower than that. So, means the time should be 50, but it is not we are getting. So, we are getting 40, it is slightly lower than that. So, then what we have to do? So, this measured value and calculated value we have to put it here. Okay. So, measured times and calculated times. So, both we have to subtract T m minus T c, that you have to calculate for data point 1. Data point 1 means for these points. Similarly, 100 minute times second data points also T m minus T c, for second data points also we have to evaluate. So, like that, if there are 1, 2, 3, 4, 5, 6 data points are there. So, total 6 T m minus T c value we have to calculate like this. So, then all these components you have to sum up 1 to n's, okay, and you have to make it square. Okay. So, then it would give a square, that is the sum of the square of the difference, sum of the square of the differences between measured times and calculated times. So, that way we can calculate. So, here is one things we have shown here, for example. So, T m minus T I T calculated for point 1, it is given 433. Similarly, all other data points also we can calculate. So, other data points we are getting a square equals to this. So, whence we have taken let us say alpha equals to 2 and k prime equals to let us say 5. So, a square is coming like this, which is far source than the first guess also. So, initial guess that was alpha equals to let us say 3 initial guess, then the sum square value is coming at 2916. So, by following step 4, 5 and 6, so sigma square value is coming, sigma square a square value is coming, that is 2916. So, by considering this guess. So, again second guess we have to consider by alpha equals to 2, k prime equals to 5. So, then we are getting a square value is 49,895. So, earlier was this, now it is getting this. So, this guess is far worse than first guess. First guess was little bit better, since a square value is lower than it is lower than this value. So, like that we have to do some other trials, means guess 2, 3, 4, 5, like that way we have to do this iteration process. So, here's one table is given. So, you can see is original data, the time and the concentrations that experimentally we have obtained, and now guess 1. So, where alpha and k prime that we are considering 3 and 5, based on that the time calculated is this. So, this is experimental measured value and this is calculated value t. So, using these equations or these equations. Okay. So, equation 3. So, now this difference of this and square if we do, so then the value is coming this. So, 4 different points we have taken and a square value is like this. So, similarly for guess 2 also we have taken alpha equals to 2 and k prime equals to 5. So, based on that also again T c value we have calculated the time, and for other different points also we have calculated T m minus T c square. Similarly, we have evaluated and sum square equals to this. So, similarly guess 3, guess 4 also we have done. So, here you can see a square value is very large value. So, like that. So, if we do this way, so a square value should be some value that should be acceptable. So, what would be that value? Means this we have done by doing hand calculations. Okay. So, hand calculations it is very difficult to predict. So, what would be the exact value of 2 and alpha and k prime value. So, so many number of trial or guess we have to put. So, now if we use Polymath nonlinear regression technique, so there's we can put these equations we can put, and then a square value automatically we can get by regression. Okay. So, here first regressions by putting initial guess whatever we have taken, after putting that. So, here's k primes and alpha value we are getting this. Second regressions also we can get, there also we are getting very close to that value. So, This would be the actuals minus R equals to k equals to k prime C A to the power alpha. So, that is equals to 0.147 C A to the power 2.04 we can say. So, this would be the rate equations. So, rate constants and powers we can get, or k prime equals to you can say k into C B to the power beta. That way if we consider beta equals to let us say 1. So, then k prime value we can get by if we know the C B concentrations. Okay. So, that way also k value we can find out that way. This is known, beta let us say 1. So, concentration of C B is known. So, then k value we can find out. So, actual equation is minus R equals to k C A to the power alpha C B to the power beta. So, here k value we can put C A to the power 2.04 C B to the power 1. So, this would be the rate equation. So, using polymath nonlinear regressions, it would be easy for us to get the value or to solve this type of nonlinear equations. So, it would be the easiest way. Okay. Now, we are going for differential reactors, example 2 we are taking, and they are also similarly by using in nonlinear regression techniques, how we can find the rate equations or different parameters. Okay. Let us say this is the reactions A plus B going to C plus D. So, here's reactant are these, this is the products. Okay. So, partial pressures or this is the runs 1 to 6 was conducted, means 6 different conditions was maintained and the same reactions was carried out, and then see here partial pressure of CO, partial pressure of hydrogens, and both are the reactants. So, that we are getting, and if we maintain 1:1 ratio of partial pressure hydrogen and CO, then we can get this product, and the concentration of that product is this, methane concentrations is given here. Similarly, for second run also we are getting this, third run, fourth run, like that 6th runs, all 6 data points we have taken. See here pressures was kept constant, only CO2 concentration was varied, here CO concentration was fixed and hydrogen concentration was varied 0.1, 0.5 and 4. So, then rate changes like this way. So, here's rate means experimentally by using differential reactors or these equations we can find out the rate. If you know the volumetric flow rate about the reactions and how much quantity of the catalyst was used. So, if we put it in these equations, that also we have discussed last time also. So, concentration of methanes that is given in the table 1.73 into 10 to the power 4 mole per dm3. So, if we put, so then rate of formations of methanes or rate of disappearance of CO we can find out this. So, these tables we can make. So, earlier this table was given from the experimental data for these reactions, and after that using these equations we have find out the rate. Okay. At different times what would be the rates at different set of runs we know. So, now we have to guess, means here's this type of rate equations we are guessing. Okay. So, or what we can do, we can consider these reactions into multiple, this is single reactions, but the reactions may pass through a number of equations, means multiple reaction steps. So, it means reactions passing through formations of an intermediate steps or transient species during the reactions, and through that by formations various intermediate or species and transient species, the reactions may pass through multiple steps. Okay. And after that that part I am not discussing, that we have discussed in your last class also, that is Langmuir-Hinseliud isotherms or equations or models that we have discussed, Marx von Kraepelin models also we have discussed. Similarly, means after discussing, so this type of equations we can get. Okay. So, here's the parameters we have to evaluate, this is nonlinear equations A, beta 1, beta 2 and B. So, these are the 4 parameters we have to find out to get this rate equations is applicable or validated for this to design a reactors. Okay. So, this similarly these equations we have, these tables we have. So, now using polymath nonlinear regressions we can get this. So, we can find A value this, B value is 2.49, beta equals to 0.61 and beta 2 equals to 1. So, this way we can A, B, beta 1 and beta 2. So, beta 1 A equals to 0.025, B equals to 2.49, beta equals to 0.61 and beta 2 equals to 1. So, by using nonlinear regressions and that tables means would be helpful, and this equations red equation is helpful. So, once we do the nonlinear regressions using Polymath software or any softwares we can use. So, then the red equations would be like this. These red equations we can use for designing reactors in the differential ordinary differential equations, design equation for a packed bed reactors, there we have discussed in previous class also. So, these red equations we can put there to find out how much weight of the catalyst are required for a particular conversion. Now, we will discuss about polymath regressions, means how polymath and nonlinear regressions we can use. So, it would be much more clear to you. So, means problems once let us say this reactions is there, and for that these 4 red equations are there. So, which ones would be suitable for these reactions? These red equations we have developed, like let us say by considering these tables, means how pressure is varied from one reactant to another. So, or directly from Langmuir-Hinshelwood models or any other models we can means choose for this particular reactions, and we can develop this type of red equations. So, which one would be suitable, that we do not know. So, from the experimental data we have partial pressure 3 components are there, component A, B, C, and corresponding red is also given respective runs. Okay. So, these tables we have and these red equations we have. So, now we have to say which one would be suitable. So, A, B, C, D. So, now we have to solve by using Polymath software. So, here you can see means first you have to install that software. So, this is Polymath Professions. So, that software we have to initially it is installed here. So, we have to open that. So, once we click, so this type of Polymath 6.10 professionals release. So, this box will comes. So, there we have to select the programs. So, once we select programs, so no regressions REG regressions will comes. Okay. So, once regressions will comes, so then tabs we have to click, and then regressions means this type of screens will come appear. Okay. So, once it is appeared, so then we have to select column. First we have to change the columns names by double clicking on it. So, we have to double click on C01's buttons, C01 buttons is there, so there you have to click. So, then these types of column buttons will come. So, here you have to change the column name. Okay. So, column means first we have rate, then partial pressure of ethylene, then partial pressure of ethane, then partial pressure of hydrogen. That way we put all data. So, in the first columns we will put rate. Okay. So, rate is appeared, we have changed that name into rates, and then second columns we have changed like this, partial pressure of ethylenes, and then partial pressure of ethanes, and then partial pressure of hydrogen. So, that way columns names we will change or rename it, and after that in the first column. So, the first row, that is the first cell, that is the rate, that value we have 1.04, that we had 1.04 rate. So, that we have to put here. Okay. 1.04 we have put here. Similarly, all data points we have to put for the rates, that columns we have to fill up. Then we have to choose these columns, and all data points we have to put for 3 components, means reactants and products. So, 4 columns we have to fill like this. Okay. So, 4 columns means rate and individual component partial pressure we have to fill up there. Okay. So, now we have filled up this rate of individual component partial pressures that we have filled up. So, now we have to click on the regression tabs. Here is the regression tab is there. So, in the regressions right side of the window, select nonlinear regression tab. So, nonlinear regression tab is there. So, that you have to select, and then first you have to select these regressions, nonlinear regressions, and then we have to type this box will appear. So, these are the value we have already put, and these are the here's the nonlinear equations or model equations, first one. So, equations A that is this, that we have to put it here. So, we have to put it here in the model equations, and then we have to select for nonlinear regression analysis LM. So, we have to choose LM. Okay. So, here by clicking here, so LMs we have to choose, okay, suitable methods. So, that you have to choose. So, once we choose that, so then we have to put the initial guess value. So, initial guess value in these equations you can see small k, KEA and KE, these are the parameters that you have to find out. So, for that 3 different components K, KEA, KE. So, initial guess we have to put it here. Okay. So, once we put initial guess value, so then we have to select next step is to for the output, means we have supplied here all rate partial pressure of individual components we have selected, and rate equations we have supplied, this is the model equations, and that initial guess of model parameters that we want to evaluate 3 parameters, initial guess 111 we have put. So, everything we have put in this equations or in this Polymath softwares, and after that we have to do the regressions. Next step is we want to get output, means the results. So, results for that we have to means in what forms or which forms we want to get. So, if it is graph, residuals, reports or store models. So, like this way we can get. Okay. So, here graphs we can click, residuals we can click it here. So, in the form of report or store models, all these we can click. Okay. So, if you check the box, so then by that way it all the results or outcome that would come, that would be stored here, okay, in C05. So, we have choose the C05 that columns. So, here also then at that particular columns that value will store, the red will store, okay, red value, that calculated value, these are the experimental value we have given provided. So, now calculated value will be come here at column C05. Okay. So, now here the ping buttons is there. So, that is we have to click. So, once we click that, so then this would be the results will come in the form of report K value KEA KE. So, it's the value is coming this. So, K value we are getting 3.34 approximate, KE value this, and KE A value is this, KE value is this, and 95% confidence limits is required. So, that is value is coming this. So, here sigma square the variance is 0.0049. Okay. So, it would like this. So, now if we this is in the form of reports, and then if we want to get in the form of graphs also. So, then this window will appear, then we have to go into nonlinear solution in the form of graphs. So, you can get it nonlinear graphs, you can get this experimental rate versus calculated rate. So, the data points which looks like this. Okay. So, if we want to get nonlinear regressions graphs, so then it would be like this with calculated experimental value and straight lines will come like this. Okay. So, nonlinear residuals value would be like this. Okay. And if we maximize the window, mean the restored the icons, here's C05 means C05, that is the columns. So, this is the columns that is calculated value, this is experimental value, experimental rate and calculated rate. First data points you can see experimentally 1.04 and calculated value 1.02 and 0.75, this is 0.72 for first and last point you can see. Similarly, all point matchings almost close to that value. So, this is by considering model A. Okay. So, by model A, so if we want to get that data in the form of Excel sheet, so then we have to click it here, the icon is given here. So, Excel button. So, if you click here, so then we will get, so calculated this type of Excel spreadsheets would appear. So, here everything is given here, calculated rate, rate residuals and the difference value also everything is coming. So, considering these models and variance also is coming like this. So, everything is coming. So, equations once we have put and we have done the nonlinear regression by using Polymath. Now, rate equation B means earlier we have taken 5 rate equations, which one would be the suitable, so that we do not know. So, if you go back, so there you can see. So, first equations we have put in this Polymath software. Now, equation 2, then equation 3, equation 4 we have to put one by ones and we have to check all those data points or that value or the result is coming. So, okay. So, now we are putting rate equations B. So, once we put rate equations B, so here similarly the model equations B you have to put, then if you click on that pink button. So, after putting and if we perform the polymath regression, so then we will get this value k and ke value that would coming this, and it is 95% confidence is this value and variance value is this, okay, variance value or you can say this. Okay. So, now using equation C also similarly if we put equation C and if you get the result. So, that is the polymath output. So, the reports that we can get. So, k value and ke value from the second equation rate equation C. So, here also we are getting variance that much and k and ke value is this, okay. By initial guess we have put 1 and 1. So, now putting rate equations D also put here and if we get the results that would be this, here's k, a and b, these are the 3 parameters will comes and then the corresponding value would be like this and variance value is this. So, now these reactions we have considered and we have considered these 4 rate equations, which one would be suitable for these reactions we do not know, but we have done the regressions and now we have to compare each result by considering this. So, now from model 1s this was the rate equations and here you can see in this particular model. So, why means out of 4 models one particular models you have to choose and rest of the 3 models you have to eliminate. So, on the basis of that basis of this the variance we can see and variance and 95% confidence limits. So, these are the 2 value we have to check and based on that so one particular models we can eliminate. So, here in this particular models the variance 95% confidence limit is 0.063 which is greater, this value is greater than variance. So, ke value if we want to analyze, so ke value 0.043, 0.042 or 3 we can say and plus minus 0.063. So, if we put, so then this value would be greater than this. So, then it comes negative value. So, it is coming k value negative value once it is coming. So, then we can reject these models, okay. This model is not suitable, okay. So, now if we go for the second models, there also we can see the k value is coming 2.1 and k value 3.18. So, here variance is coming very low value. So, this models variance is coming very small. So, then these models we can choose. So, these models may be good, but we have to check other models are also available. So, here variance value is very small value. So, therefore, we can choose this. Now, we are going for model C. So, there also you can see the variance is coming this and k value is this. So, these models also we can choose, this is also quite fitted well with the experimental results. So, but here the variance is 0.0623. So, which is larger than C in from these models variance we are getting 0.0623 and in model B that was 0.006, sigma square was 0.006. So, this model's variance is better than this. So, these models we should not accept. So, model C we are not taking, we are eliminating that. So, model B is better as compared to C. So, now model D is also there. So, there also the variance value we can see, here the variance value is this and from the model B variance was this. So, we can even eliminate these models each also. So, therefore, models B is much more model B is suitable. So, we can say that this models is means treated well with the experimental results. So, these models we can consider for this particular reactions. So, models B is fitted well. So, then we can say that for this particular reactions K P is by 1 plus K P square. So, these models here model parameters we have evaluated a small k value and K value we have evaluated. So, this value we can put. So, we can say that the model is fitted well with the experimental results, therefore, we should accept models B or the rate equations B for this particular reaction. So, how to use nonlinear regression techniques to solve nonlinear equations, that we have discussed today. So, today is up to this. So, in the next class we will discuss. So, other methods are there by using Polymath software. So, that we will discuss. Thank you.